Hello guys and welcome back. So in this video I want to show you guys how to create a particle sim that follows the shape of the geometry of the smoke sim, and it doesn't require any post-processing. We can get the result created while doing our sim. And this is something very useful because most of the time in a lot of dust type explosions you need some kind of particle within the sim so you can shade them. You can shade them with the volume to create more noise or add some debris inside the volume and things like that. And so this idea is we're going to create a new type, a new data holder, and then create a subsolver that can actually run the generation of the points. And this may sound a little bit confusing, but once I show you guys, I think it's going to make a lot of sense. Cool. So what we need to do is we need to first create an apply data node, and the reason for this because we need a placeholder. In DOPS, everything gets attached to placeholder, like fields, and data like geometry gets attached to the geometry data. But in this case, we're going to make our own geometry, and so we need our own data types. So I'm going to create a subgeo, which is the node to prepare the empty holder for it. I'm going to call this point cloud. Actually, that's custom points. And then what we're going to do is we're going to create a subsolver. This subsolver we're going to connect to the last chain of the graph. We can connect it here, but in this case I prefer to put it at the end. And you see this data name here, right now it's defaulting to geometry, and we're not going to work on the geometry. We're going to work on our new data. So I'm going to call it custom point using the same name. I'm going to dive inside. Right now it's going to import that it's going to default to importing the data called custom points, which is empty. But I can copy this and rename this field to import other things from the from the smoke sim, and I want to import the density field. There we go. Now we're accessing that data, and we have our custom points data. And what I'm going to do is I'm going to scatter some points on this guy. I'm going to turn off relaxation so it's fast, and now we have data added. And what I'm going to do is I'm going to simply merge this with this guy. This is empty at this point. We imported the density field and added some points and then merged the two together. If we go up, the points are there, but they're not doing anything right now. So if we hit play, we're going to see them being emitted every frame. They're going to respect the density field, and they're going to be emitted every frame. Well, we don't want that. This does not look like a sim to me. It's just points tracing the sim, which could be useful in some abstract type of art, but we don't want just that. So what we need to do is we need to advect these points. I'm going to create an gas advect node, and this guy is not just for fields. It actually advects anything pretty much. And the data, the geometry data that we're interested in is called, this guy is called custom points. So we want to advect that. And then the velocity field is all we need to provide to start moving our points. So let's hit play, and there we go. We have a perfect particle sim that follows the mesh. Now, the number of points is defined here. Every frame we're emitting 1,000 points. They're not dying at all. So every frame they're not dying at all. They keep they live forever. And what we need to do, what we need to do is we need to, if we want to delete them, we need to initialize some sort of age on these guys. So I'm going to create a wrangle attribute. I'm going to add age, and it's equal to 0. So we want to initialize that. And then afterward, we want to, after we add it to the previous data, this is always 0, This is the existing data that's coming from the sim. We want to increment this h. Okay, so I'm going to add plus equal 1, and this is going to happen every frame. And then we're going to add a blast node. Actually, I'm not going to add the blast node. I'm going to go back up. And there, let's dive inside. There's our sim. We're going to take a look at the points, and we're interested in that age. See, now we have the age incrementing based on the creation and on the number of frames. So we're going to put down a blast, and let's say we want to remove anything that is older than 12 frames. So age is higher than 12. We want to delete non-selected. Okay, so if we go back up now, we basically told it that the point's age is the points cannot live longer than 12. So actually I need to delete non-selected. And they're gonna start, yeah, they're dying now. You can see that. Cool. So that's pretty much how to add a particle sim within your SOP solver, within your smoke solver. Now, one issue that's going to show up is, let me increase the density of these guys, and let me reduce the size of this, and tell the container not to expand at all. So let's hit play. What's going to happen is we're going to see points stuck. Yeah, see there? They're going to get stuck in the boundaries, and we're not going to be able to delete them. So what I'm going to do is I'm going to dive inside the SOP solver, put down a delete node, and we'll want to delete the points using bounding box. Okay? But we don't have any information about the bounding box. Well, we can generate that from the density field. So I'm gonna create a bound node, and let me check one thing. Yeah. So I'm gonna create a bound node and then use a bound the bbox expression to define the size of this. So it's going to be, let me rename this. So it's going to be bbox and then relative bound for this, and then we want the x size, the y size, and then the z size. And for this, for the center, it's going to be the centroid of the bound. So we're going to use the centroid expression and get the x position, the y position, and then the z position. And this will create a bounding box. See, it's matching the sim exactly. Cool. And now we can say delete non-selected points, and anything that is outside this domain will get deleted, and hopefully this will fix all the issues that we may run into with points getting stuck onto the sides of the domain. There, they're getting deleted. Same at the top as well. Let's increase the lifespan. I want them to live for a bit longer, maybe 30 frames, and we can increase the point count. Let's hit play. Cool. And see how fast it is. It's actually really, really fast because we're not doing a lot of heavy computation. We're not using an entire particle sim. We're just creating points and advecting them, and you can see it's super, super fast. Now, the way to import this data is, okay, I'm going to create a new geo node, and let's say we want to import the data from the sim. I'm going to create a dop import, not a dop import field. Dop import. I'm going to point to the pyrosim, and let's go back. the object is going to be Pyro, and then fetch geometry from dops, and then the data name is called temp points, and these are our points. And they have velocity, they have everything needed on them. Cool. I hope you guys like this, and let's continue to the next step. Thanks for watching, and see you in a bit.